All right, let's do this. Please note, I am going to try to repeat everything that we have done last class and hopefully finish off these example questions as quickly as possible. Yesterday, we focused all of our attention on just quadrant 1. So even if you are not memorizing these, you should be able to understand that, as I said, every angle we write down, or every angle we use as a correlated, is going to add up to 90 degrees. But more than that, the angle is always with respect to the y-axis. So as I was saying, if this is 1 degrees, the correlated angle is going to be 89. If this angle is 2 degrees, the correlated angle is going to be 88. But that is strictly for quadrant 1. If I entered quadrant 2 with a large angle, what would be the correlated angle with respect to the y-axis? That's it. Always y-axis. And if you can get that, you will be able to figure out all this without memorizing. You'll be able to figure out all this without memorizing, all this without memorizing. Okay? Why? Well, take a look at these things right here. Pi over 2, pi over 2, pi over 2. Everything is with respect to pi over 2. The angle that we're dealing with is pi over 2 minus whatever I have here is the angle we use here. Right? Same thing. I am always talking about something with respect to the y-axis. Same thing. The lower side of the y-axis, so the negative direction of the y-axis, is 3 pi over 2. And it's always with respect to the y-axis. Okay? Now, my question, once again, going all the way back. Yes. If I have an angle, again, for your sake, I'm going to say my angle is 210 degrees. So sine of 210 degrees. What is the correlated angles? Now, how about I do theta and little c for correlated? Yep, that's right. How did you do that in your head?
The codependent angle is coming from the 270.
Okay, so you chose to go towards that. Some people are still unfamiliar with the y-axis, so they'll say, okay, so if this is 180, that must be 30, so that must be 60. Some people will think that way as well. Either one is fine, but since we found the 60, we can rewrite sine of something with its co-related ratio using 60. It's the same, except it's in quadrant 3. When I change my ratio into an equivalent, the only one that remains positive is tangent. So this is actually negative cosine of 60. Sine of 210 is negative cosine of 60. Shall we test it? Sine of 210 is the same as negative sine of 30 degrees, okay, which is negative 1 over 2. Negative cosine of 60, if you do the special triangles, is equal to negative 1 over 2. Okay? If you keep to the little tip, right, of the suggestion I give you, if you keep to that suggestion that every angle you get, see what angle you create with the with the y-axis, then correlated angles, equivalent expressions shouldn't be too difficult. You just have to sort of get used to it. The only extra thing you might want to watch out for is the cast rule. Consider this. In this chart, you will notice that if I use the correlated ratio for sine, the correlated becomes positive, it stays positive, right? The reciprocal ratio for sine is cosecant. If I use the correlated, if I convert cosecant, the result still remains positive. However, check this out. If I convert cosine, it becomes a negative. If I convert secant, it is a negative. If I convert tangent, it becomes negative. If I convert cotangent, it becomes negative. Moving on, CAST. If I have a large angle for tangent and I rewrite it with a correlated angle with the y-axis, the ratio remains positive. If I take cotangent, which is still tangent, right, 1 over tangent, and I write the equivalent correlated ratio, it remains positive. But if I go from sine to cosine, cosine to sine, or cosecant to secant, secant to cosecant, they will change signs. Lastly, CAST, cosine, and its reciprocal secant. If we have cosine, that is going to be converted to its correlated ratio. We have sine, it's positive. Same thing with secant. Please do not be confused. There are so many students who still make the error that since they see a cosine, they're like, oh, yeah. When I make sine into a cosine, cosine's supposed to be a positive. So they actually make that a positive. That's not true. As a summary, if the original ratio is cosine or secant, when you convert it, it remains positive. If the conversion gives you the cosine, it's not that it remains positive. That's all I can say. It's best if you practice it. So how about we take a look at practice 2 and try practice 3 and call it a day. Okay? Take a look. See how I work through these examples. The original ratio is sine. Okay? Oh, and look, I am dealing with an angle that is the lower y-axis minus something. So if I were to draw this, from the lower axis, the negative, I am moving that way. That's what it means. I'm dealing with what angle in the y-axis from the y-axis? Pi over 3. Okay. If you don't like that, how about I rewrite it as a degree? Okay. Pi over 3 is negative 60. I am dealing with sine of 210 degrees, which means I am dealing with right here. Am I recording? Yes, I am. Okay. So if I did this, I think it's a lot easier for you to digest. If this angle is 210, that angle is 30, which means the angle with the y-axis is 60. Okay, if I convert that, where do we go? Sine of 210 is equal to cosine of 60. But be careful, CAST. Only tangent and cotangent, when converted, will remain positive. Sine will change into negative cosine. And so let's answer it. Negative cosine 60 is negative half. Done. Some of you might be better with their visual. Consider this. Sine of 270 minus 60 is negative cosine of 60. Some people who have practice from yesterday or who are familiar with the pattern will see that whatever I'm subtracting is what I'm using when I convert. So there's more than one way you can get around without thinking too hard. I remember as a high school student that trying to do this and matching with the formula sometimes gave me errors and I got really frustrated. So I gave up on doing that and I chose to simply solve it with the y-axis by visualizing it in my head. I like to visualize images instead of numbers. And so that's what I did. For you, do what you think is best. Let's try it one more time. Cosine, pi plus pi over 4. I am going to pretend, again, this time I'm going to do it a little differently. This time I'm actually going to add it up. This is equal to 3 pi over 4. Okay, 3 pi over 4, through my practice, I know it's in quadrant 2. So what angle do I make with the y-axis? Yeah, it's right here, right? I make an angle of pi over 4 with the y-axis. And then cosine is converted to, well, sine, C-A-S. All right, everyone, pop quiz. CAS, quadrant 2 is S. My original is cosine. My converted correlated ratio is sine. Is it a positive or is it a negative? See there? It is a, wait. It is a negative. It's a negative. We are looking at the original. That original does not match that letter. So it will become a negative. If I gave you sine something, or if I gave you cosecant something, which is 1 over sine, then it remains positive. Yes?
Doesn't the same rule though also work if you change it to pi over 2 minus pi over 4? Pi over 4 over 4?
Say that one more time.
Can't you can just convert a sum into a difference, and then you could just do so. Yeah, so the one I did is negative pi over 4 exactly.
Okay.
And then you can just instead of negative pi over 4, you can change that to 7 pi over 4, right? Because it's 45 degrees below the midline.
Well, you're not wrong. Okay.
And then you can just say, well, that's equal to sine of 7 pi over 4, which is the same thing. That's a negative 1 over 2, since then you're in the.
Whoa, hard mode. You are not wrong at all. So what?
Seemed easier.
Woo! So what Katie is doing is, I want to see if I can make it fit these equations. I want 90 degrees or pi over 2 minus something, because if I could figure that out, I can just pluck that angle and use it. So instead of working with a plus, because that looks unfamiliar, Katie's like, well, negative pi over 4, coterminal angles, right? 45 degrees is the same as 315 degrees. And so I can turn that into sine of this angle. But since this is in quadrant 1, yes, I don't have to worry about the negative. And then you can turn that into a...
Is it in quadrant 1? Because it's 7 pi over 4. So we can see, it is in quadrant 1, but the negative, it would be negative,
yes.
right?
No, it would be quadrant
1, that's right, but it's negative. It's just that, right? Because quadrant 1 is negative.
Yeah.
Yeah.
Oh man, I have to think about this because I've never done it this way before. Sine, so that would be, so it would become a -1 root 2 over 2, which is the same as negative root 2 over 2. I guess it works. I'd have to check it out.
Wait, root 2 over 2? 1 over, oh,
Yeah, no. So yeah, pi, yeah, 1 over root 2.
Okay.
I'd have to check it out to see if this technically it counts as quadrant 1 because it follows the 90 minus angle situation, or whether it's something else. But it seems like it would work.
Even if it doesn't, there must be a way to do it so that you use the same.
True. So
Basically the
you
same
can
operation.
you can simplify things for yourself. Yes, but let's make that into a you and me discussion as opposed to the class, which is totally fine, but it might confuse people. Let's try one more time. Okay. So as you can see here, I've done it by figuring out what the y angle is, right? After adding it together. Other people might simply match your question with the actual formula and use this accordingly, okay? I don't know which one works for you. I'm gonna do it my way by figuring out what quadrant this is. So this would be, right? 3 pi over 2, which is the lower half of the y-axis, the lower direction of the y-axis, plus an extra little bit. That, I'm talking about this angle here, which means the angle that I create with the y-axis is the pi over 6. Tangent in quadrant 4 will be equal to correlated cotangent of pi over 6. However, since this is CAST, the ratio of tangent must change to a negative when I do that. Which means negative, let's see, tangent pi over 6, it is a 30 degrees. That is 1 over 2 divided by 3 over 2. So 1 over 2 divided by root 3 over 2 is 1 over root 3. So this would be negative root 3 over 1. I think that's right. My brain is not working very well, but it's what it is.
2 over 2 root 3, right? Which is.
Yeah, you know what? Just in case, let me do it. So we've got cosine pi over 6, sine pi over 6. That would be cosine of 30. It's root 3 over 2 over 1 over 2. Yes. So if I divide fractions, it's like multiplying the reciprocal. It's negative root 3.
Solve for cotangent.
Correct. So tangent is sine over cos. 1 over tangent is 1 over sine over cos, which is the same as cos over sine. They're reciprocals. It's literally just flipping, yeah. So it works out. And that's it. That is equivalent expressions. What can we do about these crazy practice questions? Well, we can give it a shot. I'm going to do the first one, try to model it for you, see how this kind of T question could play itself out. It's a lot easier than you think. And then I'm going to ask you to try sine pi, 8 pi over 9. Why does a question like this give you a decimal? Well, a denominator of 9. You're not familiar with it. That's the whole point. If you can't use a calculator in a question like this, what would you do? Well, here it is. Sine pi over 9. It doesn't seem very related, but since the question gave it to me, I'm assuming there's a trick. I'm going to rewrite this as sine 2 pi over 18. All of a sudden, do you see a relationship, sort of? Sine a 7 pi over 18, 2 pi over 18. Think about it. If I wanted to convert that into a cosine, pi over 18. That would be pi over 2 pi over 18. That would be something like that. Okay. If I was interested in turning 2 pi over 18 into a subtraction from 90 degrees, or pi over 2, minus something, what would that something be? That's right. 9, well, yes, this entire thing would be,
Oh, so you could use
right? That 90 degrees is equal to 9 pi over 18. So what is this portion out of 9 pi over 18? Yes, that's right. So 7 pi over 18 is 9 pi over 18 minus 7 pi over 18, which means if I wanted to convert into cosine, we have that. So in other words, trick question, sine pi over 9 is cosine 7 pi over 18. Therefore, sine pi over 9 is 0.3420. This question actually gave you the answer. They just wanted you to get to it. Okay? So here it is. Here's a question where I give you sine, but the clue is cosine, which means that's a signal for you to somehow turn it into cosine. Oh, do we have to go? Oh man, that was fast. Okay, maybe you can try that at home and see how far you get. We can finish this off as a homework check tomorrow. Please give these equivalent expressions a chance. Textbook examples are a variety, are there for you to do. We'll see you tomorrow.